In this question, we're told that an open box is made from a square sheet of cardboard with sides 1 meter long. We create the box by cutting out a square from each corner, folding up the sides and joining up the cut edges. The question would like us to calculate the maximum capacity of the box. So first thing we're going to do is draw out the situation. So we have a square piece of cardboard that is 1 meter by 1 meter. We are then told we cut out a corner. So we cut out all of the corners. And let's say each of these was x by x. What we then do is we remove these corners and fold it up to create our box. So our box is going to have a length of 1 minus 2x and a width of 1 minus 2x and a height equals to x. So the question wants us to find the volume. So recall that volume is equal to cross-sectional area multiplied by height. So in this question, our volume, which will be a function of x, is equal to the cross-sectional area, which is equal to 1 minus 2x times 1 minus 2x, so that is 1 minus 2x all squared, times by the height, which is equal to x. Now what we do is expand out these brackets, and on doing so we'll get x minus 4x squared plus 4x cubed. Now this gives us our volume as a function of x, and this is a function that we want to maximize. So we know to find the maximum of a function we need to do dv by dx equals to 0. So when we differentiate this function we'll get 1 minus 8x plus 12x squared. Now we can factorize this to give us 6x minus 1 and a 2x minus 1, which is still equals to 0. So that tells us that x is either a half or x is equal to 1/6. Now clearly if we take x equals a half and go back to our original picture, we'll see that if x equals a half, what we're actually doing is dividing our piece of cardboard into 4 quarters, and we would have no box. So we can safely ignore this solution. So we just have x equals 1/6. Now we need to confirm that this does in fact maximize our volume. So to do so we need to calculate the second derivative. So calculating the second derivative we'll get minus 8 plus 24x. Now what we need to do is evaluate this at x equals 1/6, and so that gives us minus 8 plus 24 times 1/6, which is minus 8 plus 4, which is equal to minus 4, which is less than 0. As it's less than 0, that tells us that we have a maximum point. So we know that x equals 1/6 gives us a maximum. We now just need to find the volume, and to do so we just substitute x equals 1/6 back into our original equation. So what we'll say is that v is equal to 1 minus 2x all squared times x, and so when we sub in x equals 1/6 we'll get 1 minus 2 times 1/6 is a third, all squared times by 1/6, So this gives us 2/3. So we have 2/3 squared times 1/6. So that gives us 4/54, which we can simplify down to 2/27. Therefore, the maximum capacity of our box is 2/27 meters cubed.